here. In today's episode, I'm going to set up a Raspberry Pi camera. I have a Raspberry Pi 4 at home and a camera I bought off AliExpress, and I'm just going to assemble it and I'm going to set it up. And at the end, I'm going to create a live stream, which I will use then to access the camera itself from my own computer. So what are you waiting for? Let's get started. So I have a Raspberry Pi here. This is a Raspberry Pi 4 with 4 GB of memory. I'm going to connect camera, which I bought off AliExpress. It's not the actual official Raspberry Pi camera. It's a camera I bought, well, it's very similar and it's compatible. What I'm going to do is I'm going to connect the camera to the Raspberry Pi using this CSI connector. The blue side of the ribbon needs to point towards the back of the Raspberry Pi, yeah? And then you just basically fasten with this fastener, so it's secure. It won't come off. But anyway, I'm going to take it off again because I also have a case for my Raspberry Pi. This case, I downloaded the file of Thingiverse. This box is inspired in the Google Vision kit that they've sold some time ago, and I've just added a hole here so I can basically slot in the camera, and this hole is actually perfect for this camera because I've designed it in Blender. Just cut a hole. Right, so what I'm going to do, I'm first going to put the camera into the box. For that I need to take the lens off, yeah? So once I take the lens off, basically what I need to do is I need to do this basically. So the lens itself is going to secure the camera to the box, which is nice. So I don't need to use any additional screws. That's why I did it like that. But the only disadvantage is that I had to remove the lens, and that will make the camera out of focus. But then I will be able to fix it once I start using the camera in the Raspberry Pi. It's all good? Yeah? Now it's time to connect the camera to the Raspberry Pi. Blue ribbon facing the back, and if it isn't, forgive me for that. That's what I remember. It won't damage the camera anyway if you get it wrong. Then you can just swap it. So now I can basically, you can use screws here, or you can just use hot glue, which is what I normally do. I have some hot glue. I can secure the camera to the case. It's quite easy to remove it if I need to. Okay, so now everything in place. Close the lid, and I have my Raspberry Pi camera ready to go. Looks quite nice, isn't it? This type of camera here is not the only type of camera you can use with your Raspberry Pi. There are two other types of camera you can use. The first type of camera is a USB camera, which would use a USB cable, and you could connect to the Raspberry Pi. What is the difference between the camera that we're using now and the camera that would be connected via USB? There's an important difference. First of all, in terms of data transfer, the camera that we're using connects via a CSI connector, which is called the camera serial interface. It goes straight into the board. It's very fast, right, in terms of data transfer. That has advantages and disadvantages. The advantage, of course, yeah, the speed. The disadvantage is that you are limited, because for each camera that you connect via this CSI connector, the operating system needs to have the appropriate drivers for it, which means, so if you look at the Raspberry Pi offerings that you have, you only have 3 types of cameras available. The version 1, which is the oldest, version 2, and then a more recent type of camera that camera sensor you can use is the Raspberry Pi Camera HQ. Those are only 3 types, but there are so many more cameras out there. So for our project, we don't want to actually be limited to the camera that the Raspberry Pi offers. I'm going to show you how it works. I'm going to show you the APIs, all the bells and whistles, but if you actually want to do some serious work with video, you can't just use a Raspberry Pi camera. It's okay for fun, right? But if you want to be more serious, like we are right now, we want to identify wildlife, we want to have the most amazing cameras with low light capabilities that you can find. Yeah, that's the main thing. I can actually go into more details, and you know, if you actually buy a camera which has already some image processing capabilities included inside the camera, then it's going to actually save a lot of the work from the Raspberry Pi. So the Raspberry Pi won't have to spend a lot of CPU or a lot of its GPU trying to process the images that come out of the camera, because the camera itself will do that for you. It will give you the image already in the format that you need it. All the enhancements that come with all the cameras out there. For instance, these cameras, their own GPUs, and they can actually do a lot of enhancements to the image that it's going to save a lot of time from the Raspberry Pi. So you can save CPU from the Raspberry Pi, which then you can use in other things more appropriate, like AI, right? All right, so now we are going to set up the camera. So I've just connected it to the Raspberry Pi, and I need to just follow a couple of steps to basically enable it. So first thing I need to do is to run sudo apt update. So after I've run sudo apt update, I should do an upgrade as well. So I'm going to run sudo apt full upgrade. So it's now downloading all the packages from the Raspberry Pi repositories and updating my Raspberry Pi to the latest version. And now I need to enable the camera via the raspi config utility, which you can execute via the command line. My user has root access, so I'm doing sudo raspi-conf. So I go to interfacing options and I select P1 camera, and then it will ask me if I want to enable the camera, and I say yes. And at this stage I should reboot. Okay, I'm back in business. So I've rebooted it. Now I can test the camera. So I'm going to take a picture from my camera. Right now the room is going to be quite dark, but that's okay because I want to show you later on a big difference on lighting. -V for verbals, it gives me more output, and if something goes wrong I'll be able to get a proper error message. -O is output, and then I give it a file name. So I'm using a remote desktop. So in theory, if I was actually directly connected to the Raspberry Pi, I should be able to see a 5-second preview of like the camera, what the camera is seeing before it actually takes a picture. Yeah, so it kind of took a picture, but it didn't show me any a preview, which is a bit annoying, but it doesn't matter. As you can see, there's this picture. So I'm going to take a picture. So -V for verbose, -O for output, and then the name of the file, test JPG. So it should take a picture. If I was directly connected to the Raspberry Pi, I would also see a window showing me a preview of the camera, but I'm not. So, okay, so you can see a picture here. So the camera is working, which is good to know. I've actually switched on the light to be able to see how it looks like when there's enough light. And I'm going to take another picture now with less light, and you'll see the difference. So I've changed the name of the picture so I don't overwrite the previous picture I took, and I'm taking another picture with low light just to see the difference. You see the difference? This one looks a little bit pink, doesn't it? It's to do with the camera itself. Okay, this is nice, but ideally I wanted to actually get some footage out of the camera. So FFmpeg is like the Swiss knife of video. If it's the case that FFmpeg doesn't have the drivers I need, then I might have to compile a new version or get a new version from the internet. And I think there's a couple options for that. If I have to do that, I'll go into more detail. So I'm going to create an RTSP stream, and I'm just going to find... RTSP is actually something that you can use for live streaming. So what I'm actually showing you now will allow you to create a live stream out of your Raspberry Pi camera quite easily, just using FFmpeg. Okay, so let's try this. this first. So I'm recording first a video from the Raspberry Pi before I try to create a live stream. So this is creating a 5 seconds video. The Raspberry Pi actually outputs everything in H.264 format. This is it. 5 seconds from the camera. So if I want to pass in the number of seconds I want to record, I can pass in 10,000, which is 1 second is 1,000 milliseconds, so this is 10 seconds. So I'm going to go and just wave at the camera. That didn't work. Okay, so let's, by the way, I'm using a remote desktop, so the quality of the image is not necessarily given any justice here. So I'm going to record a 30 seconds video. Okay, so now I should have enough time to go and put myself Oh, you see my hand, yeah? It doesn't seem to be a very high frame rate. So it's not doing justice to the camera, by the way. I want to control the frame rate. This gives you a lot of flexibility for whatever project you might have. It's to do with the resolution. The actual Raspberry Pi camera has different resolutions and different frame rates based on the resolution. Should be this table here shows it nicely. So I'm using the camera module V2, and that gives me a 1080p, which is 1080p at 30 frames per second. But if I go lower resolution, 720p, that gives me, it allows me to do 60 frames per second, and so on. You can see it's much smaller now. So just now it was actually in a high resolution, and that's why probably the frame rate was a bit low. It's much smoother, but bear in mind as well, this could be in real life. If you're directly connected to the Raspberry Pi, you should see this much more smooth. But I'm using a remote desktop, which makes things look worse than what they actually are. Okay, so I can capture a video from the Raspberry Pi camera. I would love to get the streaming to work. I need to just remind myself. I'm sure I've done it with FFmpeg, but right now this is all I can find. So at some point I will search for this for what I was doing before. But this is also a valid method. So if you look at what's doing here, it's basically collecting images from the camera itself, and it will indefinitely. So I'm not actually, so here is -T0, so, which means it will go on forever. And then I specify the resolution here and the number of frames per second. It seems like in this example, they've made it low enough. I'm not sure about how it is going to work, but let's hope it works. So I have a live stream. This is from my Raspberry Pi. So I'm going to go in front of the camera. I'll wave my hands. I'll switch on the light as well, just to make it a little bit brighter. We set a low frame rate on purpose, and yeah, this is good. So I should be able to access this as well from my own computer, and I'll try that as well to see if it's any better. This is over the network, not from the Raspberry Pi itself. As you can see, it also works. So this is looking good. So let's try and improve a bit the resolution of this. For a higher resolution, 1920 and then 1080. I'm going to switch on the light. I'm going to wave my hands. Yeah, I'm just going to do one more time. Can actually stream at a higher resolution. Okay, the image quality is not great, but that's because I don't have very good lighting. Let me just up it a little bit, see if I can get it better. There's many settings I can change to make these even more optimal. This flashing is because of the lighting that I have. You know, you can actually see the frequency here. The camera can record it, but anyway, other than that, it looks quite good. This is good enough for me. Okay, I can play a lot more with some of the settings, improve. You know, there's many parameters in Raspberry Vid, but I think I've kind of demonstrated the point. So I'm actually streaming on with RTSP protocol. In order for me to put this on YouTube, I could even stream it on YouTube. I'll try to do that some other time. In fact, I'm planning to do that. You know, when this project is basically working, I want to live stream a feed of my garden. I don't think I'll do 24/7, but I will stream a few times from my garden so people can see if there's any wildlife coming or not, and hopefully you'll spot something. I won't need to actually look at the live stream 24/7 because I'm going to have some AI on top of it. Now, I wanted to do one extra thing. I have another camera. So I have two more cameras actually, and these are very special cameras, especially this one. This small camera is a low light camera. It's with a Sony sensor. This camera is much better than the camera I have in the Raspberry Pi. Yeah, it cost me like, I think 20 pounds, not even that. And this has a special type of sensor which is capable of actually recording anything in low light with color, right? You can actually, there's plenty of cameras that have night vision and can record quite well if you have there is a lamp normally that you use an infrared lamp that these cameras will have that will shine light onto any subject, light that we can't see with our own eyes. These cameras will work well, but this camera doesn't need that up to a certain point, really. When there is a little bit of light, it's able to use that small levels of light to actually record the subject. So these are special cameras. It's not something that you can get on a Raspberry Pi. Okay, the Raspberry Pi has three types of cameras, as we've seen just now. You have a 5 megapixels, 8 megapixels, and 12.3 megapixel. I haven't tested the HQ camera, but it looks really cool. A bit expensive. If you actually want to buy this camera, it will cost around £100. If you have another way of connecting cameras to your Raspberry Pi, then you don't depend on the Raspberry Pi. You only have three options here, right? So if you use a USB camera or even an independent camera, and you are able to connect that to the Raspberry Pi, you can add some intelligence on top of it. You're not limited by the cameras. So you have a lot of options. So this camera is in 4K. I don't need 4K for my project, but you know, 4K is nice to have, so I could use this camera. And it will always do better than the Raspberry Pi camera itself. These cameras will also have their own autofocus functionality. They'll do everything that we, to be honest, things that we don't really want to mess around, like, you know, like the aperture, ISO levels and so on. These cameras will do everything automatically. They'll be optimal. They were designed in a way where you don't have to mess around with those parameters. So I want to connect this camera to the Raspberry Pi and in this way see if I can get better image out of this, but this will take a while. So I'm going to just get the power supply for this and I'll get started very soon. I've connected the low light camera to the Raspberry Pi using the Ethernet cable, and I also used a separate power supply. Now what we're going to try and do is to see if we can basically connect to the camera via the Raspberry Pi. The reason I connect the camera into the Raspberry Pi and not directly to the network is so I don't overwhelm the network in my house, right? Because can you imagine like a camera streaming 1080p 24/7 on your network is going to eat a lot of bandwidth, and I don't want that to happen. So the only time I want my network to be used is when the Raspberry Pi detects something interesting in the camera that the camera is recording. Other than that, the camera itself will never stream anything over the network unless I want to. So that's why I've used an Ethernet cable to connect my low light camera directly to the Raspberry Pi. And the challenge now is to try and access the camera via the Raspberry Pi. I can forward RTSP stream from the camera itself via the Raspberry Pi, which is what I'll do next. So I'm going to create some kind of tunnel. Let's see how we can do that. Okay, the first thing I need to figure out, so I've connected the camera into the Raspberry Pi. You see, this is my Ethernet network. It currently has no IP address. So I need to assign it an IP address, which will allow me to access the camera itself. And I used to have like a copy and paste command to do that. I know this camera has a fixed IP address, so as long as I'm in the same subnet as the camera, I should be able to access it. Okay, I think I know what it is. So if I do if config if 0 192.168.1.1, so I'm just assigning myself an IP address and then a net mask. I think it's a good idea as well. I could
In theory, what I should really be doing is to configure the Raspberry Pi to assign IP addresses on whatever connects via the Ethernet cable. I think I want to avoid having to do that if I can. So I'm just manually assigning an IP address, and I'm hoping that in this way I can ping the IP address of the camera. We should be running okay, it's not, I need to figure out how to create a route. I kind of forgot how to do that. So it's actually quite good. I was able to set a route that allows me to access the camera, and now I'm going to just try and use VLC to basically open the RTMP stream. I'm just going to open it again. So I'm going to have to search for the right URL. I have the URL because I know the camera. I also know it has a password, which is not very secure, but this is only visible within my network. It's not exposed on the internet. In fact, it's only visible within only the Raspberry Pi currently can access the camera. And hopefully this will work. Nice. Okay. So I'm going to point the camera at something, but I can tell you it's very dark. You might think that I have my lights on right now, but I don't. It's pretty dark over there, and I'm going to make that point by I'm going to start again the live stream I had before, and then you'll be able to compare the two. Yeah. So what I'm going to try and do now is to start again the live stream I had created sometime before. Okay, this, you see this live stream. So I'm going to actually connect the Raspberry Pi camera. Hope I don't kill the Raspberry Pi by doing this, because it's streaming from two places at the same time. So if I open another stream, you'll be able to see the difference. Okay, the camera is in a slightly different position, but as you can see there you see on the right hand side, that's where the camera is. So I'm going to try and open it. Hopefully I can open both at the same time. No, it doesn't let me do that. But look at this. You can see ping here. Well, I think this is because of the infrared the camera is using. So the camera is not able to see things in color because it's too dark. If I switch on the light, you see that now I can see things in color. The other camera is amazing. So I can open it from here. Going back to the previous stream, you can see in good light. So this is with light on. I'm switching it off. You can see it's still light. Yeah, I mean, like, what else can I say? This camera cost me like 20 quid. It has basically low light capabilities that you only see in very expensive cameras normally. And I connected this to the Raspberry Pi, and now we have a very powerful camera that we actually can use outdoors. In fact, I'm not going to put it outdoor because I don't want, this is not waterproof, the camera, neither the Raspberry Pi, but I have a window facing my garden, which I can just place the camera there, facing forward. I don't have to worry about the fact I have a window. And the problem with cameras that use infrared, this is a strange thing. If you have an infrared light pointing towards a window, it will basically, it's not transparent, the window. If you're using an infrared light, you can't record through a window. You need to place the camera outdoors. But if you have a camera as powerful as this one, which has a sensor capable of recording in low light and in true color, then it doesn't matter, right? Because you're not using infrared, so you're not going to have an issue with any windows that I might place in front of the camera. So it's pretty cool. I hope you enjoyed it. I think for today, this is going to be enough. So we have here the basic tools. I've used the Raspberry Pi camera, which is connected directly to the Raspberry Pi. I can get it to work. However, we are limited by the cameras that the Raspberry Pi supports, which are very limited. We only have 3 types of sensors that are supported at the moment, which means if you want to have some really advanced features, you can't really do it. It's no good. But if you use an Ethernet cable, and you can connect any camera to the Raspberry Pi, as long as the camera itself uses open standard protocols. And that kind of widens so much your capabilities, what you really can do with AI and with a good camera. There's also USB cameras, which I have tried one in the past. The idea is the same. It might be slightly more convenient because you don't need to have a separate power supply. So you connect the camera via USB port, and then in this way you basically can record whatever you want. Basically, the camera itself is independent from the Raspberry Pi. It has its own image processing APIs and functions. And you can get also low light cameras, some good ones, with USB connection. The only issue I found is that you can get cheaper cameras with Ethernet cables on. If you are willing to use a separate power supply, then you have a lot more possibilities in terms of cameras you can choose. But if you don't want to have a separate power supply, then I would go with an USB camera. Okay? So I think this is great. Yeah, I'm happy with the progress we've had. So the next episode, I'm going to be trying to run OpenCV and capture the frames from the Raspberry Pi camera or from this low light camera. And then once we are able to capture the frames directly from the camera, we can apply some AI on top of it. If you like this video, smash the like button. If you would like to watch more videos like this, please subscribe, and see you again soon. Happy coding!